different color. Um, if you guys were in ninth standard year, you might have understood as to how I teach chemistry. But anyways, I'll give you my experience. Please don't get offended. This is exactly how you're supposed to learn chemistry, at least for a second PUC, or else things will start going over the head. That's the guys. 1 minute. I'll change the microphone. Yeah, done. I'll tell you my perspective towards chemistry. I'm not gonna see. Let me scare you guys initially, and then tell you on fact. Chemistry is a subject where a lot of equations are involved. In fact, haloalkanes, haloarenes, organic chemistry put together, approximately you'll be coming across minimum, including CET, 2,500 to 3,000 equations. I'm talking about full organic chemistry. Okay, organic chemistry. Organic chemistry. Now, should you sit and mug up each and everything? Obviously, no. Majority of them, minimum 80% of this specific equations will follow one order. Now, what is that order? Okay, we'll try to understand that order first. See, basic concept of chemistry is there's something called as the left hand side, right hand side in math. No, so similarly, there's something called as reactants and products here. The reactants will always break up, the products will always get formed. Basic math. So in simple language, on the reactant side, there's always breakup happening. On the product side, there's always love happening. So this whole concept of breakup as well as love on this toxic equation happening and this toxic relationship happening in one specific equation will be called as chemistry. That's it. Okay. Should you learn anything more than this? 100% no. Huh?
Sir, can you explain this again?
Yeah.
Sir, I
Wrong.
like just now learned.
I make it. It makes complete sense. You can.
Sir, I just now learned. Sir,
Then I'll
tell.
repeat what I told. Okay. Then you'll realize why I'm laughing. Correct.
Yeah, tell, sir.
I said chemistry in second PUC has 3,000 equations in organic chemistry. 80% of them follow one order. Called left hand side is called as reactants, right hand side is called as products. So each and every time breakup happens on the reactant side and love love happens on the product. Sorry, breakup happens on the rare. It's very rare. Now, fluorine, it is used. I'll give a number. Let's say 80% of times we tend to get the answer within both of them. The remaining 15% of the times fluorine will be used and iodine is very rare. This 15% times wherever fluorine is used, almost all those spaces, there's a concept called as exception. Now, wherever chemistry is there, especially in your 12th standard, exception will always follow. We don't have a choice. So wherever exception is there, it makes it that more important for us to remember. You cannot ignore stuff is what I'm trying to tell you guys. Okay, so wherever chemistry there, exception is there, you got to remember it. And I told something else, I forgot. Yeah, anyways, we'll talk about that a little later. Exception. Okay, now fluorine, should you learn all the equations based on fluorine? Yes. Okay, I will tell you what and all to ignore, but majority can learn. So this is the dark side of chemistry. Now, what's the easier side of? You want me to bet whatever, I'll do it right now. Based on PCM, if you focus little on chemistry, I'm not even telling more, little on chemistry, that's what I'm trying to tell you. If you can give chemistry equal importance, mark my words, chemistry easily you'll be able to score more than 45 to 50 out of 60. Okay, I'm using the word easily. Now, math also you can do, but it is not easy. You're supposed to put in that effort there. Okay, chemistry is like once you understand it, there is no application of things which have been asked in your 12th standard. Okay, they'll be like, you learned this, we'll ask a question based on it, so please come and write it. That's how things work. Okay, so CET perspective, very very easy. PUC perspective, they tend to play around. Okay. Usually PUC paper only chemistry will be difficult. Now, what do I mean by difficult? So if you know your PUC paper, the first main will be something called as MCQs. They tend to play a lot with MCQs. In simple language, they tend to give you MCQs based on CET. So in other way around, throughout the year, if you're actually preparing for CET, indirectly you can also answer these MCQs without any hassle. Okay. After MCQs, those 2 markers, 3 marker, 4 marker, and the numerical part in chemistry, everything is predictable. These 15 to 20 marks is where they tend to play around a lot in chemistry. I'm talking about PUC. But if you can focus on your CET, this problem also gets solved. Okay, that's how it is. Now let's jump into haloalkanes. I was talking about halogen. Done. Alkanes. I need not explain this. 10th standard. Initially, when you guys were introduced to something called as organic chemistry, you guys had to learn about alkanes. The same thing is there. Now, what happens is in your 12th standard, for each and every organic compound, haloalkane is an organic compound. Haloarine is an organic compound. aldehydes, alcohols, everything, all these organic compounds, you're supposed to learn something called as methods of preparation. Now, the other day I sent you a PDF for physics. No, later tonight, maybe I'll send you a PDF based on chemistry for the same errorless book. You will see there are so many methods of preparation printed in errorless. Should you learn everything? Please don't do it. I'll tell you what and all to learn. Now, talking about the first, please don't write anything. Also, just keep focusing. Don't even write anything. I'll do this love and breakup thing for almost all the equations. So first method is called as from alcohols. So what does this concept called as from alcohol mean? End of the day, my main concept here is haloalkanes. I am trying to get haloalkanes using alcohols. That's the meaning of it. And obviously in 10th standard chemistry, you guys might have come across something called as R, also called as alkyl group. Alkyl group. Let me give an example. CH4, this concept, guys, please focus. This concept is, this name is called as methane, but also called as an alkane. Okay. So from an alkane, if I subtract one hydrogen, I'll repeat that. From an alkane, if I subtract one hydrogen, whatever remains, that will be called as alkyl. So CH4, the complete thing is called as alkane. You remove one H from it, so it becomes CH3. Now this will be called as methyl. Methyl. So if I ask you guys to write ethyl, you'll first write ethane initially, and then from that you take off one H and it becomes ethyl. Always remember, alkane and alkyl are interrelated. Without alkane, alkyl won't exist. Similarly, without alkyl, alkane won't exist. Both of them show dependency on each other in a very solid way. Now, again, I am trying to get haloalkane using alcohol. In 10th standard, you might have also come across this concept called as alcohol. The representation of alcohol in chemistry is done by OH. Now, don't tell sir, we know the basics why you're trying to eat our heads, but can't help. Now, what do? I could have taken some random examples. For example, methanol, ethanol, all these things I can take, but I will not take anything specifically. I'm only interested in trying to learn the general methods. So 1 minute, I'll write from alcohols again. So generally, how do we derive or how do we write alcohol? You first write R, called as an alkyl group. To this alkyl group, you attach OH. Now this becomes an alcohol. Okay. Now understand, you will add something called as X. Now don't get confused with this. You've been using this almost in all the equations in chemistry so far in your life. Have you guys used something called HCl or HBr or HF? Obviously, everybody would have used it. This is very general. This is very specific. What is Cl? What is Br? What is F? Just now we learned they belong to a category called as halogens. Any halogen will be represented by X. Any halogen. So instead of me writing HCl, HBr, HF, I am just writing HX. So now what happens? So you guys realize that both of them belong to something called as reactant side. So what happens? We are expecting breakup to happen. Guys, understand, 100% love cannot happen on the reactant side. Impossible for it. Okay. It has to break up. Now, how do we break up? We have two parts here. We'll have to break each of them separately. Okay. Now I did that. First, you write the letters separately. Okay, the groups, letters is the wrong word. First, you write the group separately. H is a group, X is a group. Once you separate them, this is when you'll start adding signs. Common sense, OH OH based on your valency chart is called as hydroxide. OH minus is what we keep on telling. So automatically you put a minus here. If this is a minus, automatically R will be a opposite sign called as plus. Now the complete world knows that H is positive compared to X. So now we are done with this. Now what did you do? You broke the groups down. You also distributed the charges. Now careful, the most important part. You'll have to think from R's perspective. R currently is positive, and the full concept of chemistry, full subject of chemistry usually is based on only one rule. What's the rule? Opposite signs always attract each other. Okay, now think from R's perspective. R is positive. It wants a partner. Now, it will obviously look for somebody who's negative. It has two choices. Either it can go towards OH minus again, or it can go towards X minus. Two choices because both of them are negative. Now think from R's perspective. If it goes back to OH minus, don't you think the same compound will be formed? This should not happen. Why should it happen? It will become toxic. Okay, I need not explain that in the depth of it. Okay, let me give you a very philosophical view of this. Little chemistry is also involved, but let's see how smart you guys are. Why shouldn't R go back to OH? Okay, I told you it's toxic. I used a very nice word. But the actual concept goes like this. In a forest, if you see the same tree twice, it means you're lost. Okay. Now I'm leaving up. I'm leaving the sentence up to your imagination. Whatever you guys feel, you guys can apply. But I am using a. It needs a change. Yeah, it needs a change is what. Okay. But I told in a forest, if you see the same tree twice, it means you're lost. Anyways, toxic is the word. So automatically it does not choose OH minus, which means it obviously has to choose R. I mean, it obviously has to choose X minus. So now R plus as well as X minus will combine and form a compound. Now, when they form a compound, automatically these signs will go off. Why? Plus gets cancelled with minus. So the answer becomes Rx. R is called as an alkyl group. Guys, focus. R is called as an alkyl group. X is called as an halogen group. Haloalkyl or alkyl halogen in other language called as haloalkanes. Also called as two names. Alkyl halide, it's called as alkyl halide or haloalkanes. Both of them mean the same. Now, obviously, guys, also understand that the initiation of the what do you call it? The product will always happen from somebody who's positive. Now R got combined with X, so they formed a compound. Now who's left? OH minus is left, and H plus is left. Always remember the initiation should always happen from the positive side. Now H plus attracts the OH minus, it becomes H2O. So this concept, this formation of Rx will be called as haloalkanes. So we used alcohol, we used HX. R needs to. Ajit, I think the Christ College in you is talking. Okay. Anyways, R, shit. Anyways, from alcohols, understood? No, you take. I mean, don't add anything. I'll send the things later to you, but automatically now see this so much toxicity and all is happening there. It needs a catalyst. Now, usually, what's the catalyst? It's something called as anhydrous zinc chloride. Anhydrous zinc chloride. Now, why am I only using zinc chloride? Don't I have any other choice? I do have a choice. Usually, what we do is see now. This is a general equation, correct? Now, I'll let a specific example. Instead of taking R, I'll take CH3 because that's an alkyl group. You combine that with OH. Alcohol is formed. Now, I'll take HCl. Anhydrous ZnCl2. Now, why Cl2? I told Cl2 is here, so Cl is here. That's why. Okay. Now it became what? CH3 breaks up and obviously combines with Cl. It becomes CH3Cl plus H2O. The actual name of this compound is called as methyl chloride, but it also belongs to a category called as haloalkanes. Haloalkanes is a group, a category. This here is a specific example, methyl chloride. Okay, so from alcohols, we derive. Any doubt here? Either unmute and ask me right now or put up in the chat box, do something. I'll give you 10 seconds. If there's no doubt, we'll go on to the next one. Quick. I just want to introduce this concept to you guys. Oh, understood. Very nice. Let's go to the next concept. Just like the way we guys used alcohol right now, we'll use some other stuff. There's something called as phosphorus halide. Phosphorus halide. What's the purpose of ZnCl2? So the whole concept is it's a catalyst. Now what does it do is in the midst of this toxicity, I'll tell you where things can go wrong. Now there are literally 50% of chance that R goes back to OH minus again. Okay. Why? Because negative. The ZnCl2 is the only thing which will redirect R plus towards the X minus, telling this is not required because it will become toxic again. And the redirection will happen only in presence of a catalyst. In this case, the guide here is ZnCl2. That's how it is. It has to change the path and direct it to a better partner. Okay, that's how it is. Cupid. Fine. Next, phosphorus halides. I'll use the word halides here because there are two examples under this. So what does this mean? Just like the way I used alcohol and got haloalkanes, I am trying to use phosphorus halides. I am trying to get haloalkanes again. Now let's see how is this possible. First, the only advantage here is, okay, phosphorus halides. The reason I wrote plural there is because in our syllabus, we have three things. We'll have to use PCl3 and PCl5. Please remember, I'm using the word and here, not or, which means I'm supposed to frame two equations. In the first equation, I'll be using PCl3. In the second equation, I'll be using PCl5. Let's go with the first one. Now, what do? I'll take one example here. Because anyways, I gave you a general equation. No, I'll take an example right now. CH3, CH2, CH2. So count the number of carbons. 1, 2, 3. 3 meaning propyl, propanol. Okay, propanol. Remember this. To this alcohol, can you see in the first step and the second step, I'm keeping the alcohol as the same. In the first step, along with alcohol, you used HX, hydrogen halide you used. Right now, we are using phosphorus halides. Okay, I'll add the first one, PCl3. Now, please be careful as to how these things work. Now, here the thing is very simple because phosphorus is kind of stronger. A little heat is required, is good enough for the thing to happen. What do you mean by for the thing? For the concept to take place or the equation to go on. Now, understand one thing. You want the answer to be haloalkane. Haloalkane. Now, you look at both the sides. You look at the first part, you look at the second part. You realize the only halogen used here is chlorine. Agree? That's the only halogen used. None of the other things are what you call halogens. So keep this in mind, which means 100% whatever happens, there has to be chlorine here. Whatever happens. Got it? Now, automatically, 1 second. I think this is kind of confusing if I put this. Yeah, now it's better. Little gap I'll give at it. Chlorine has to be there. Now, this part, okay, let's do the same breaking up part here. This part breaks up. This it becomes the positive part, R part. This becomes the negative part. Common sense. Now, this positive part attracts whom? Negative part from this. Now, please focus here. Now, what not to get confused? The distribution does not happen like this. No, because chlorine is Cl1 minus. You can't just put random numbers there. Okay, so keep that in mind. Very, very, very important. So now what happened? You did not know how to break up the second part. No worries. You take the first part here, which is positive. You think in this circled part, in PCl3, whom do you think will possess the negative charge? Obviously chlorine. Obviously chlorine. Now this positive part will come and combine with chlorine. CH3, CH2 and CH2 got combined. Now obviously you'll ask me a question. Sir, what is this? There were 3 chlorines on the left hand side, but you only put 1 chlorine. See, I never told I will involve all the 3 chlorines directly, but I will involve, but not directly. So what do I do is, since there were 3 chlorines on the left-hand side, but only 1 chlorine here, I'll balance it with the number 3. So since I put a 3 here, I'll obviously have to put a 3 here. Understanding how the balancing works. Very important, guys. So I'll repeat that again. In the first part, you broke up. You realize what is negative, and see, basically in the first part, OH only can be negative, hydroxide. You put a minus. The complete remaining part will be positive. Obviously, this positive part, somebody wants somebody who is negative. You look for somebody negative in the second part. You know that chlorine is negative. Okay, go ahead. You attach that positive part with chlorine and the product was formed. But the problem was there were 3 chlorines used on the left side. There is only 1 chlorine used. Now, how do you compensate that? Obviously, by balancing the number. So since you put a 3 there, this part also has to get balanced. You go back here onto the left-hand side and put a 3 here again, and it got balanced. Okay, so far so good. Now I'll tell you, okay, now let me scratch off what and all. Okay, use a different color. What and all got used up in the equation. I'll just keep scratching off. Cl3 got used up, balanced also. This part got used up. Okay, now understand this 3 belongs to 2 things. One, the positive part and also the negative part. Okay, one, the positive part and also the negative part. So can I tell on the first part, there is actually 3 oxygens remaining and 3 hydrogens remaining. I hope you guys understood that. Because the 3 belongs to both the positive as well as the negative part. Positive part got used up completely here. Negative part, O was there, H was there. 3 was there before it. So there are actually 3 O's and 3 H's. But there's only 1 P. Now remember the second rule in chemistry for 12th standard. Okay. So whatever is left out, 3 O is left, 3 H is left, and 1 P is left. Look for the minority. Who do you think is minority here? Obviously, phosphorus. Always remember one concept here. Okay, I'll give you a better example, but it will become controversial. Anyways, forget it. Not required. Okay. There was 1 P minority here. This minority wants love from both the sides. That's the rule. Okay, remember that. Any minority will want love from both the sides. Now, what does both the sides mean? There is 3 oxygens, there is 3 hydrogen. Now, this P wants love from both the sides. So, how does it get love? It goes and sits in between. Now, you tell me, in chemistry, what makes more sense? If I write H first or O first? Obviously H, because you might have seen many things with O, but usually what makes more sense is H being first. So you write H first. P is in between. Why? Because that was the minority, and whatever is there in minority will require love from both the places. Okay, and you put O there. Now automatically you tell me, sir, the number is not balanced. How many H? 3H. If I put the number 3 next to it, it becomes 3H, 3P, 3O. Wrong. The 3 should only belong to H. So therefore, I put the 3 next to, below H. P 1. So no number. Oh, how many were there? 3. Again, if I put a number 3 here, it changes the context. So I put the number 3 below. H3PO3 is called as phosphorus acid. Phosphorus, sorry, my bad. H3PO3 is called as phosphorus acid. Got the thing as how it works? I'll repeat that. Polar also is true, but again, that's why I twisted and told you. Minority, requires love from both the sides. Guys, I didn't tell this concept of minority only for this question. I am telling this will work for, you will see me repeating this minimum 20 times in the course of doing organic chemistry. Okay, minimum 20 times. Whatever is minor will always require love from both the sides. Always. There is zero exceptions based on it. Okay. Now, I hope it made sense. You take one alcohol, you realize the big part was positive, the smaller part was negative. You break it up, but you guys got confused in the breaking part here. No problem. Your positive part will attract the negative part here. Chlorine is negative. You attached. Done. But the problem was the numbers. Chlorine was 3 number. To compensate this 3, you put a 3. The moment you put a 3, you had to balance it from the first side also. You put one 3 here. Now what happens? This 3 belongs to O and H. It became 3O and 3H, and only one P was remaining. So this minority will require love from both the sides. And both the sides meaning the only, see guys, I'll tell you what I mean by both the sides, okay? H is there, O is there. If I write P first and H later, it is not getting love from both the sides. Only H is getting. Getting love from both the sides in simple language means it has to form bonds between both of them. Now, if I put P first or last, it will only form bond with either H or O. But I wanted to form bonds with everything. So therefore, you'll have to be a little strategic there and make sure you slide it in between. Okay, like a sandwich, and then you get an answer. Fine. This is how PCl3 works. Now, how does PCl5 works? I'll tell you. For that, what we do is we take the same number of carbon atoms. Here I use 3 number. No, I'll take the same 3, but little change I'll do. So 1, 2, 3. In the first case, the alcohol was attached to the end carbon. Now what I'll do, in the second case, I'll take the same alcohol, but this time I'll attach it with the center one. Got it as to what I did? Now we obviously fill the H. There, this carbon is one is there, guys. Wherever, okay. One more thing. Let's revise this. Wherever hydrogen goes, 1 bond follows. Wherever oxygen goes, 2 bonds follow. Wherever nitrogen goes, 3 bonds follow. Wherever carbon goes, 4 bonds follow. This is one standard rule in chemistry from 9th grade. Okay. Now automatically carbon is 1 here. Just now I told you wherever carbon goes, how many bonds follow? 4 bonds follow. Out of 4, 1 is already done. It requires how many more? 3 more. Therefore, it makes step. Automatically, the breakup this time will happen here. The bond will break there. Okay. So this complete circled part becomes a positive version. This part becomes a negative version. Okay. So keep this in mind. Now, this positive part will attract whom? Somebody who is negative. Now come back to the right side. Who do you think is negative and completely free? This chlorine is free. This chlorine is also free. So this positive part will attract the most nearest chlorine. And the thing looks like this. It looks like CH3, CH3 was there. The OH gets replaced and Cl came and sat there. So 1 minute, I'll use a different color. This part got utilized with the big part. The positive attracted the negative. The main answer I got. But are we done with it? Not yet. Because there are a few more things to satisfy here. Now understand, once the breakup happened, OH came out. How many? 1 O is left, 1 H is left. Remember this. Here, PCl3 is left and Cl is left. Let's do some matching here. O was left, H was left, PCl3 is left, Cl is left. 4 things are left. Now, let's start with H, the most positive one. Think and tell, guys. H being the most positive will attract somebody who's negative. In the complete box, who do you think H will love? It will obviously love Cl because most positive, most negative. So automatically, H and Cl will combine and form HCl. Okay, H and Cl will combine and form HCl. Now think, there is O left and there is PCl3 left. Who do you think is alone and who do you think already has a team? PCl3 already has a team. O is alone. Now, just now I told you, alone or minority both mean the same. Whatever is alone or is minority in number, it always requires love from both the sides. Correct? So now O will go approach PCl3. If O goes sits here, it is only forming bond with P. If it goes and sits on the right side, only Cl. But that shouldn't happen. Just now I told you, it should experience love from both the sides. So therefore, PCl3 will allow O to come in between P and Cl, and it becomes POCl3. Now I'll tell you the crazy part here. This here is a yellow liquid. It's called as phosphorus oxychloride. Oxychloride. That's a yellow liquid. CHLO, whatever. Okay. This becomes an explosive. It's actually an explosive. Okay. So the moment it gets love, understood as to how it explodes, that's how things work. So initially, for PCl3 and PCl5, what's the change? The placement of which is the change. There, you approach it from the sideways. Here, it's more from the middle. Done. It breaks up. O is there, H is there, and done. This positive part gets attracted with the negative part, gets cancelled. Okay, the complete Cl part was done. Done. Whatever is remaining, make sure you guys keep writing it here. O was remaining, H was remaining, PCl3 was remaining, Cl was remaining. Okay. How do you figure out the minority in all the equations? Array, psycho. Look at this. H is there, Cl is there. Got used up. Huh? HCl was formed. Now O is there, PCl3 is there. Who looks more dominant? PCl3 looks more dominant. Uh, Not all equations will have minority. Yeah, not all equations will have minority. Don't worry. But wherever it comes, you're supposed to use the same logic. Got it? Yeah. So basically, H and Cl got. I mean, obviously, they combine. Now O was left. Say PCl3 was left. Who do you think is alone or a minor? O. So automatically, it wants love from both the sides. It becomes POCl3. Simple, straightforward. 100% board exam question. PCl3 or PCl5. Now I've taught you both, but see, one thing to avoid, please don't write it as PCl5 directly, okay? Write it as PCl3, Cl on the one side, Cl on the other side. It's easier for you guys to, you know, understand it. See, I realize this is the main product, but all the attention this one takes. Hey, it's an explosive, man. People get scared, okay? And this is not as dangerous as this explosive, but yeah, that's how things work. But yeah, keep this in mind. Got it? Now, there's something called as SOCl2. We'll have to use that also for preparation. Now, what I'll take two carbons, CH3, CH2 I'll take. Along with this, again, alcohol only. See, I'm still using alcohol. Yeah. Along with this, you're supposed to add SOCl2. SOCl2. But again, I am not comfortable writing SOCl2, so can I write it as SO? I'll keep dots on two sides. Cl. I hope you guys are understanding as to how I work. No, right now, like it is much more easier to um, differentiate it. And always remember, usually, minimum 60% of the times, wherever sulfur is being used, pyridine will be the catalyst. Please learn this. Okay, please learn this. Pyridine will be the catalyst. Now listen. Let's go. Start here. The bond breaks here. This whole thing becomes positive. This whole thing becomes negative. This positive part, somebody wants somebody negative in the second part. Who do you think is the closest and negative? Cl. Closest and negative. So both of them combine and it becomes CH3, CH2, and a Cl. Okay. First part done. Plus. Now OH is left. Okay, now, wait. I'll write down whatever is remaining. O is remaining, H is remaining, SO is remaining, Cl is remaining. Correct. Now I'll put up in all these four elements. Let's try to match one pair. H will obviously go with Cl and form HCl. Now SO is there, O is there. Think who is minority in number? O, which means it requires love from both the sides. So this O will come and sit in between. It becomes SOO. Can I write SOO as SO2? That's it. But understand the middle O is always this. It's always this. It won't matter, but I'm just trying to tell you in your perspective. So as to how I'm taking one specific aspect and solving all the equations only based on that. So it's just you break up, you find the closest opposite partner, you combine them, and then you write down the remaining elements, and you try to pair them up. You try to find the best pair. Usually it is essential only. Okay, best pair there. And the minority one will always want to go and sit in between it. This concept only, this equation, wherever pyridine is used and SOCl2 is used, a special name is given to this, okay, called as Darzin's reaction. Darzen. Okay, Darzin's reaction. Also important. Any named reaction will be important. Got it? So just by using alcohol, we learned three methods. One is using, one is taking alcohol, reacting with hydrogen halide. Hydrogen halide. Then we went to the next step, one step complicated. We took phosphorus halide. We took two examples. We learned it. Then we took the same alcohol. We combined it with, okay, guys, SOCl2 has a name. Always remember, sulfate is what we keep calling it as. The actual name is called thio. Okay, wherever sulfate is there, thio will be there. So this thing will be called as thionyl chloride. Okay, thionyl chloride. Wherever sulfur is there, this thing, chloride, thionyl chloride. Okay, the whole process is called as Darzin's reaction. Now, don't get scared. Names are kind of complicated, but I'm not asking you to sit and mug up the names today only. No, as time keeps passing by, you guys keep getting a knack of it. Now, this is the first method, using alcohol. Second method is called as halide exchange. Okay, halide exchange. See, half the concept will understand just by reading the thing. Halogens are getting exchanged. Okay, which means both the left hand side should have some halogen. So how do I write? Okay, under this there's one method called as Finkelstein's method. Finkelstein, Finkelstein. Very important. Okay. Now I'll tell you how I used to remember this. Think. Halide exchange meaning left hand side, both of them should have halogen. That's why you can exchange. See, bro, let's say I'm trying to exchange t-shirt with you or a jersey with you. You are giving me one jersey. In return, I'm giving you my jersey. So it's always a 360-degree loop here. It is not one side business. It is both the sides. It has to happen both the sides. The deal is involves both the people here. Okay, same way. So I'll take R, obviously, because alkyl group. I'll just put X plus. Now you take sodium. Why sodium? That's the most basic thing. Along with that, you take I. Fine. Now what happens? Common sense. Halide exchange. This X here goes and sits at I, at the place of I. Similarly, I comes and sits in the place of X. That's all. So what will the answer be? It will be Ri plus NaX. Now, teaching this is very simple. Remembering this only is difficult. Okay. Now I'll tell you how I used to remember this. Finkelstein. Okay, there's one more concept after this called as Schwartz reaction. After the Schwartz reaction, I'll stop today's class. Okay, but please focus. Finkelstein and Schwartz are very confusing, is what people telling. Will keep telling. Why? Even though the concept is very simple, just you're replacing it. They don't understand when to use what, and is there any catalyst here and all. They don't understand. Okay, so I'll tell you how I used to remember this. Fine. This is how I used to remember. Now, it completely depends on your thing. Okay, I used to remember it as fry. When you fry chicken, fry. Okay, but what I used to do is regularly the spelling of fry is FRY. I used to change it to FRI. Now listen to the story here. You're trying to fry something. Common sense. Whenever frying is required, you obviously need some kind of heat. Because without the stove and heat, do you think you'll be able to fry something? No. Along with heating, don't you think you require some kind of oil? Getting it? So it's a process. Finkelstein, F. Okay. Fry. Okay. So F in fry means Finkelstein. What does RI mean? RI means the answer. Correct? RI means answer, which means if the concept or if the question asks you, write Finkelstein reaction, you write fry first, which means RI has to be the answer. If RI is the answer, don't you think the left hand you'll always remember? Because I, how did it come and sit there? It got replaced with X. So which means automatically X will be here. Getting it? So people used to get confused here. And the remaining process I need not explain again. That's very simple. But remember it like this. To fry. Now understand. You understood the concept of fry here. We also realized that in order to fry something, you need heat. So you write heat also as a catalyst. But you can't write oil. Okay, obviously some kind of thing is required, but you can't write oil. Some kind of liquid is required. What that liquid here will be called as acetone. Okay, liquid here is called as acetone. Fine. Now, how do you think acetone will be? Will it be just like oil? No, it will be more like, how do I explain? Have you guys seen Lysol at home? Lysol or Harpic? I think Harpic is a bad example. Lysol. Okay. Same consistency. Acetone will be in. The color will keep changing, obviously. And this acetone, okay, it is used to. There are many movies. There are many movies where they use acetone to extract drugs and all from from statues. So sometimes people, when they're trying to transport drugs from one place to another place, they tend to mold it in statues and then they keep traveling. Okay, the only nobody gets to know, and the only way it separates is by using an acetone. If you dip that specific mold in acetone, the drug comes out. Okay, so acetone will be more like a Lysol, but you should understand it as oil. You require oil. That oil here is acetone. You require heat done to do what? To fry. In fry, F means Finkelstein reaction. RI meaning the answer, and you exchange and halide exchange happens. Very important three marker. Sorry, very important two marker. Okay, called as halide exchange method. So the next time I ask you Finkelstein reaction, now don't tell sir this is too kiddish, brother. You're learning 3,000 equations. Now who the fuck is asking you if it is kiddish or not? Are you getting the answer or not? Is my thing. Is it kiddish? Who cares? Get the answer. That's it. Okay.
Sorry.
Hmm.
Sir, do they directly ask what is Finkelstein reaction?
Yeah, that is one way. Or they give you a blank here and a blank here, and they'll be like, fill up the reaction, or name it and balance it.
Oh, so they give you the reactants and stuff.
Yeah,
like,
sometimes they give. But usually it is like write the balanced Finkelstein reaction.
This is balanced.
Yeah, it's balanced. No, I mean you can't balance a general one, Dhiraj.
Yeah, that's what
R
I'm.
ಬರ್ದಿದ್ಯಾ? ಅದಕ್ಕೆ
Is
balance
it
ಮಾಡಕ್ಕಾಗಲ್ಲ.
a general form or like?
No, you can write general form only. You'll get. Got it, huh?
Yeah.
But this is the concept, guys. When you're trying to see, don't mug this up because this is called common sense. I'm pretty sure you guys have seen people frying, okay, kebabs and shit like that. Okay, but yeah, see, think of the requirement and you'll be able to get the answer. Now the problem is, Swartz reaction also works on halide exchange. This I'm telling you, but how do we remember it? Okay, listen up. Swartz reaction involves F. So here we are not involving F because I is being involved. Here we use F. How do you remember that? I'll tell you. So the reaction goes like this. You take R anything Rx. I'll take Rx plus AgF. The moment I told AgF, it was very close to KGF. No, I mean that's not a hint anyways. I'm just trying to tell. Rx with AgF. Now obviously tell me the answer. What will happen? This X will combine. I mean will replace the F there, and the F will replace the X there. Correct. RF plus AgX is the answer. Now, Fry was for Finkelstein. For Swartz, listen. The hint is surf. 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 Are not surf excel, are mental. Surfing, surf. In surfing, take off the U. Huh? In surfing, take off the U. What is remaining? S. Swartz. RF. Answer. Done. And to surf, you need water. But just imagine if you put water here, do you think makes sense? Obviously, no, because water is there in the atmosphere anyways. So, no catalyst. Understood? See, no catalyst meaning there's moisture. Fine. You need not write moisture because when surfing, you require water. Correct? So, that's the concept. Fry is for Finkelstein and the answer is RI. For Swartz, you write surf. You take off the U. So S is for Swartz. You ignore. RF will be the answer. If RF is the answer, obviously you'll have to reverse engineer and get this answer. Got it? Huh? So whatever I did only in today's class, minimum 5 marks will come for your board exam. Minimum 5 marks. I am not trying to tell everything will come only as your question answers. Fill in the blank, MCQ, match the following, whatever. Today's class, 5 marks will come. Got the hang of how chemistry works in 12th standard? This is chemistry. Fine. Now, the reason I gave this intro here is because, first of all, it's important. And second of all, I want you guys to understand this is how you're supposed to learn chemistry. Or else learning, please write, if you can come up with the most lame story and if you can remember it, please do it. Okay. Or else just follow whatever just remember whatever I tell. Because that's how I used to remember. I used to connect all these things to some random story, which I don't forget, and I used to come up with the thing right there. Okay. Yeah. Yeah. Padraj,
Sir, will, you told they'll ask. So how do I tell? Sir, general form only will be. General form only they'll give awards, sir.
you stop asking these lame questions. I told be lame in forming the story, not asking questions.
Seriously, sir, 11th grade it was hard when you thought like this, and in the exam I had to look at those long equations.
I don't look at the long equations.
Bro, what are you
Bro, if I
doing?
teach the long equations right now, your seed will get affected. You know that?
No, sir, will you teach with examples is what I'm asking.
Okay, now let's say CH3, CH2I. Huh? Okay.
Yeah.
Write a story based on this and give me an answer like this. Let's try. Let's see.
Bro, will you teach in like further classes?
No, further class in the sense wherever it is required, I'll teach. Finkelstein reaction, it is not required. Schwartz reaction, whatever we did in today's class, it is not required. See, here, look at this. PCl3 and all these things. Did I take general here? I could have taken general, no?
Yeah.
So, the reason I took specific example is because they'll ask just like this.
Okay.
Look at this. Here also I took specific thing. Here also. Thionyl chloride, again specific things. So I'll take general things wherever it is asked. That's all.
Oh, so if they ask this, they might ask general only.
Yeah. Now Schwartz they might change because R can be CH3. In this case it can change. But that's why I told for Schwartz remember RF. F is there. F is important for Schwartz. Getting it? But learning and understanding the meaning of Schwartz will happen because of this concept called as surf. So if you want to learn it using that surf concept, it's difficult for us to take a specific reaction and then try to form a concept based on it. But the other stories, whatever I'm trying to tell you in chemistry, okay, that will be involving your specific things only. Not everything is general.
Yeah.
Correct?
Yeah.
Any doubt, guys? Understood how we work, how this works? Fine. Now listen. Today, solve differentiation from the beginning, whatever I did, in a separate book. Okay. Now I'm not asking you to complete off everything. Whatever I've done, how much ever you guys can do it today. I want, if you can minimum finish 50% of whatever I've done, it will be of great use. Fine? Because it's been a while since we did this math, and I do not want you guys to forget it. Because next time I see you there and be like, sir, did you teach this? And I kind of hate it. So if you can do the differentiation, just keep revising your inner function, outer function. What happens when both the letters are not the same? And if you can just touch the basics and revise 50%, it'll be nice. Got it? Okay. So yeah, do this till by the end of the night. And today I put on lens because it was raining. Yeah, saw how heavy it was raining. More often than I'm baking. Today was raining. But still, yeah, correct. Yeah, you'll come off. Yeah, how will I come? Anyways, okay. See you. Bye.